Hey guys, all right, so this is our throwback skill for the week. After this video, this will be the last thing that you'll have for this week. So once you get this finished and all of it submitted for the days before, you'll be done for this week, okay? Week 2, we're almost finished. All right, so this is another throwback skill. It kind of goes with the one that we did last week. It was solving systems of equations where you graph two lines and you try to see where they intersect. Last week we talked about substitution. This week we are going to solve it by elimination. Okay, so just like with substitution, you're going to run into different situations where you'll have to solve them differently. So if you want to pause the video real quick and go ahead and write down these notes, you can. Again, we are going to be solving for elimination. And it's called elimination because our goal is we are trying to eliminate a variable. So with substitution, we substituted a variable so that we were only working with one variable instead of x and y. This time we're going to try to eliminate x or y. Okay, so these are the two different scenarios that we're going to be looking at. We're going to be looking at one when one of the equations need to be multiplied, and the second one when both of them need to be multiplied. Okay, so again, take a second, pause the video, write those notes down. Whoops. All right, so let's focus in on this way first. All right, so we're going to do this when one equation needs to be multiplied. Now, this video is going to be really quick because we're not actually going to solve them. We are just going to get them started, and we'll solve them in the practice just like we did with substitution. Okay, so we have our system of equations here, and we're trying to, if we were to graph them, see where they intersect. But first thing I notice is that none of them are already solved for a variable like we would want them to be for substitution. All right, but if we look up here at this little tip, it says that one of the equations needs to be multiplied. Okay, because what you're trying to do is you're trying to match the coefficients. Now that spelling's probably wrong, but remember the coefficient is just that number in front of a variable, and when there's not a number in front of a variable, it's understood to be 1. Okay, so we're trying to match those in both of our equations. Okay, so you do that by multiplying them. Okay, so what I see right here is that since I have a 1, I could take this equation and I could multiply the entire thing, both sides of the equal sign, by 4. And I chose 4 because if I multiply 1 times 4, then both of the coefficients in front of my x will be 4. Therefore, I have matched that coefficient. Okay, so watch what happens when I do that. So I have to multiply that 4 by everything inside my parentheses and on the other side of my equal sign. So I get 4x plus 40y equals 12. All right, I didn't do anything to the second equation, so it's just going to stay the same. All right, so like I said earlier, we're trying to match the coefficients. We did that right here. Those coefficients match up now, so I'm free to eliminate them. Okay, so in order to eliminate them, we want them to equal 0, so it's not there anymore. So what we have to do is we have to either add these or subtract these in order for those x's to cancel out. Now, if we were to add them, we would get 8x. And then we'd get 45y, and we'd get 17. All right, that didn't help us at all. Okay, so let's see what happens when we subtract them. Four x minus 4x, that is 0. 40 minus 5, okay, so a positive 40 minus a positive 5 is going to equal 35y, and then 12 minus 5 is 7, okay, and then we could continue to solve this out, but that's not what we're doing right now, okay? So that is one way that you can solve this. Now let's look at another one. Okay, so that is how you would solve it by elimination. Now again, we'll continue solving for the variables in the practice, but right now I just want you to focus on the elimination part. Okay, so this one, once again, our goal is to match the coefficients. So I can see, wait. All right, so this is the same one. There's another way that you can do it, okay? So I can see that none of the coefficients match up. I have a 1, 10, a 4, and a 5, okay? So this time I could multiply my equation, my first one, by a negative 4, okay? So then I would get negative 4x plus, see, I made a mistake a lot of people will make because I forgot to distribute it all the way through to everything. So then I get negative 40y equals negative 12. All right, and then I didn't do anything to my second equation. And that stays 5. Okay, now this one's different. Obviously, you can see that now we're working with all negatives up here. So in order to eliminate a variable, we're not going to subtract them this time because now I have a negative 4 and a positive 4. So if I were to subtract those, whoops. If I were to subtract those, I would get a negative 8x, okay, which again doesn't eliminate my variable like I want it to. Okay, so this time I would have to add them together. Okay, so those would cancel. That's a negative 40 plus 5. So that would be a negative 35y equals negative 12 plus 5 is a negative 7. Okay, and then you would continue to solve for your variable. Okay, whoops. I don't know why that Z is there. Okay, there it goes. Okay, so that is what you do when you only have one equation that needs to be multiplied. So let's go down to the next set where you have both equations that need to be multiplied by something. Okay. Try those on there. Okay, so again, we want our coefficients to match. Now, automatically I see this 2 and this 2, but because they are with different variables, you can't count those as being coefficients that match. Okay, so those wouldn't work. It has to be my x's matching up and my y's matching up. So I noticed that I'm probably going to have to multiply both of these equations in order for them to have a matching coefficient. So I see right here I have a 3 and a 2. So I know that I could multiply this one right here. I could multiply both sides of it by 2. And I could multiply both of these by negative 3. And once I did that, I would have 6x. I'm going to change that. I'm going to do a positive 3. I have a 6x minus 4y equals negative 14. And then I have a 6x minus 15y equals 30. Okay, so you have to remember again, multiply it all the way through on both sides of your equal sign. All right, so these are my 2 new equations. Now, we're still working with the same lines. We know that if we do the same thing to both sides of the equation, we're just creating an equivalent equation. Okay, so we're still going to end up with the same solution because they're equivalent. All right, again, remember our goal is to eliminate a variable. Well, we do that by getting coefficients that match. All right, I see my coefficients for my x's match up, so those are they're perfectly set up to be eliminated. All right, so I have a positive 6 and a positive 6. If I want those to be eliminated or to equal 0, if I add them, that will give me 12. If I subtract 6x minus 6x, that will give me 0, which is what we want to do. So I'm going to have to subtract these two equations from each other, because a positive 6x minus 6x will equal 0. All right, and then that's a negative 4 minus a negative 15. Okay, that is negative 4 minus negative 15. Okay, so that's like saying negative 4 plus 15, which would be 11. So that would be 11y equals, that's a negative 14 minus 30. So that would be a negative 44. All right, and then you're set up to solve for y. Okay, so you can see that because these coefficients matched up, then we were able to subtract them from each other in order to eliminate them. All right, let's do it one more time, and just to show you that you don't necessarily have to do it this one way. There's multiple ways to do it. Okay, so last time I said I was eliminating my x, and that's what we've mostly been doing on all of these. Okay, so let me show you here that you can also eliminate your y value as well. All right, so I have a 2 and I have a 5. Okay, well, I know that there's a multiple for 2 and 5 of 10, so I could multiply this one by 5, and I could multiply this one by 2, and then that will give me 15x minus 10y equals negative 35. And then I have 4x minus 10y equals 20. All right, so immediately I see that my coefficients right here match up. They both have a negative 10. All right, so if I'm wanting to eliminate, what am I doing here? If I'm wanting to eliminate these, then if I add them, a negative 10 plus a negative 10, that would give me negative 20. If I did a negative 10 minus a negative 10, that would give me 0. So what do we want to do? We want to subtract them. We want to subtract these two equations from each other. Okay? Because a negative 10 minus a negative 10, if you don't trust me, go to your calculator. Negative 10 minus a negative 10 is 0. Eliminated, which is what we want to do. Okay, so those cancel. Then I have a positive 15 minus 4, that's 11x. I have a negative 35 minus 20, which is a negative 44. And we can solve for x. Okay, all right, so that is how you do elimination. Unlike substitution where you solve for a variable and place it in there, plug it in like we say, you are just creating equivalent equations so that you can eliminate a variable. Okay, now remember, do the practice. We're actually going to solve those out and then we'll be done. Thank you guys.